Morning, good morning. We wait 2 minutes and we start to also be on time. Oh, see, one, two more. Okay, that is here. Perfect. We wait 1 minute and then we start, everyone. I hope that you can all see my screen. It should be fine normally. And we will then slowly start with our EWA IFAT webinar, water reuse and public health, regulation and risk management in Europe. And we will now start. So good morning, everyone. My name is Arthur Guichet. I am Secretary General from the European Water Association. Again, welcome to this EWA IFAT webinar on water reuse and public health, regulation and risk management in Europe. I have a few slides before we start with the first presentation. As you could see on the top right and on the titles, and this webinar is part of our IFAT Munich 2026 activities. IFAT Munich is a trade fair that will take place on May 4th to 7th, and it's the most important industrial meeting point and the heart of the largest international platform for environmental technologies. So they expect over 3,000 exhibitors from more than 60 countries that will present their strategies and innovation and also solution. And a part will be focusing on water recycling and circularity. And especially if you look for, or if you work on water, then you will have the blue stage where we'll also have a session about water reuse. So that's also why we do this activity today, which is the first one that will lead us to IFAT next year from EWA side on the blue stage. And what's happening on the blue stage is like you have sessions about sustainability and climate adapted water management, water reuse, such as ours for today, and energy efficient wastewater treatment plant, and so on and so on. So that's, you have it. And you also have EWA codes that you can use to get free tickets and for IFAT next year. Then the European Water Association in a nutshell, and I swear this slide and the next one, and then we will really start talking about water reuse. So EWA, we are an independent, non-governmental and non-profit organization dealing with the management and improvement of the water environment. So we have members from nearly all European countries. We have national members, corporate members, and research members, and we see ourselves, or we aim to be, a forum for discussion of key technical and policy issues in Europe, such as the development of water reuse and the water reuse regulations that we'll be talking about today. And we then arrange conference, workshop, meetings. We have working group of experts that you'll hear a bit more when I will introduce one of our speakers and our website. Quick info about today. So you can use the chat as some of you already did to exchange between each other, but please use the Q&A box in order to submit your question to the panelists. And I would be also really grateful if you can also mention for which of our speakers your question is directed to. And please note that we cannot respond to the raised hands as all participants are muted. So please use the Q&A box for the questions. Please note that this webinar is recorded and will be available on YouTube. And because I saw the questions, all of our speakers have agreed to share the presentation with you. So after it, you will receive an email with the link to the recording and to all the presentation. So that's all from my side. So I will start sharing that one. I will introduce our first speakers before sharing a presentation. So our first speakers for today is Dr. Roberta Maffetone. You are an expert in water reuse and wastewater treatment with a strong focus on risk management. You are holding a PhD in environmental engineering and have extensive experience in developing and implementing EU guidelines and regulation for safe water reuse. as a scientific project officer at the European Commission Joint Research Centre, you play a key role in advancing the EU water reuse agenda, collaborating with stakeholders to promote innovative solutions and best practices for water reuse, And your scientific work encompasses risk assessment methodologies, treatment technology, and policy development with the ultimate goal of protecting public health and the environment while promoting sustainable water management practices in Europe. I think everyone that works in Europe on water reuse already knows you, Roberta, and knows your face. Once again, thank you very much for being with us, and I will share your presentation in a second, and we will be good to go. Wait a second. Up.
In the meantime, thank you very much, Arthur, for the introduction, and good morning, everybody. So I don't have to introduce myself. Thanks a lot. And I'm very happy to be here on this webinar on the EWA, looking at the IFAT conference. And to start up with an introduction on the water use regulation, focusing on the public health protection, so I can to have a link and a connection with the following speakers that will focus on a more specific subject. So I will then you can go ahead. So just as a reminder, we are working for the Joint Research Centre, which is the department of the European Commission that provides support on the on scientific and technical parts of the whole European policy cycle. My unit is the Ocean and Water Unit. We support development on water governance, and we are based in the site of Ispra in Italy. Next one. So why water use matters for public health? We saw that with the water resilience strategy, public water use also became, along with the other policy and programs, at the center of the European Union agenda. There are mainly three different aspects when we are looking at the public health protection. Of course, water use is one of the solution to face increasing water scarcity and climate pressures. We can look at wastewater, treated wastewater as strategic resources, but still considering the protection of the public health and of the environment, with public health being a core objective, which is a core objective of the water use regulation. Next. So the water use regulation was a necessity, mainly to harmonize the standards of reusing treated wastewater for agricultural irrigation within the European Union. For the very first time in Europe, so from 2020, with this regulation, all the member states, they are following the same rules when it happens to reuse treated wastewater for agricultural irrigation, focusing on water quality, defining in 4 classes, but it also goes beyond minimum quality requirements and requires, for the protection of public health and the environment, the drafting of a risk management plan when a water use system is implemented. Next one. So when we are looking at the minimum requirements of the water use regulation, going back before during the drafting stage of the regulation, the minimum requirements were based on a scientific study conducted by the Joint Research Centre that determined the microbiological indicators that are part of the quality classes from A to D of the water use regulation, based on a quantitative microbial risk assessment, considering the exposure scenario of consumers eating raw vegetables irrigated with the treated wastewater, And the same approach was used to identify validation monitoring requirements that determine the log removal values that they are defined in the Annex 1 of the regulation. So it is all based on a comprehensive already, when we are looking at minimum requirements, a comprehensive risk-based framework for the protection of public health. And then next one. In addition to the numbers, so to the water quality requirements, the regulation also demands the drafting of a risk management plan. Risk management plan, that is a process that is required in a whole water use system, in collaboration with all the actors involved in a water use system, to identify additional hazards within the system and assess their risk, and they identify management actions to further protect, of course, the public health and environment. With this, the JRC has supported the development of guidelines for risk management plan that they were then used. They were the basis of the other supporting implementing act, supporting the water use regulation, so the delegated regulation 1765 that was published in May 2024, and now it represents the legal requirements of the risk management plan, and along also the guidelines on the application of the regulation that have been published in 2022. So next one. But the protection of public health and to maintain the regulation doesn't only require to meet the specific minimum requirements and additional requirements identified during the risk management process at the point of compliance, but mandates requires to ensure that all the risk and the health risk are maintained from the point of compliance, also when the water is delivered to the next actor in the chain, so usually it's from the reclamation facility operator to all the other actors that they are handling the water use system until the point of use. So this concept is strictly embedded in the multi-barrier approach. That is not only the one that is being used before the point of compliance, where we see multiple treatments that will ensure that the pathogens and also other contaminants are removed effectively, and they are catched if something is failed in the treatment chain, but also after the point of compliance, when we have many other type of elements, including transportations and irrigation techniques, that they have to be looked at that as also as a way to still protect the public health and enhance the safety of the quality of the water used. So this is what the regulation is suggesting when it talks about the use of barriers after the point of compliance. And with this, the JRC is currently developing a multi-barrier approach guidance with the University of Bologna and SEDEX, the Centers for the Experimental Studies of Spain, to give practical examples on how safety and can be ensured also after the point of compliance using different types of treatment and actions and practices that are already in place in agricultural field to achieve an equivalent or higher health protection that was already achieved at the point of compliance. So to maintain this throughout all the chain. Next one. And complementary also to this, I just wanted to highlight that the JRC, we are also conducting, we are running the EU wastewater surveillance for public health, which is a dashboard collecting the analysis conducted in the raw influence of urban wastewater treatment plants and analyzing specific pathogens and pollutants up from the wastewater treatment plant, and we are based on a strong super sites system, which is a world super site system where it's a network of wastewater treatment plants that are currently analyzing and reporting the data to the JRC. And this we are looking into how to implement these results to further understand how then we can increase the risk management practices within the water use system. The next one. And then just to give an overview on how since the implementation of the adoption of the Water Use Regulation 2020 and the adoption of the rules from 2023, how the European Union is uptaking the regulation. We have in green the member states that they intend to implement the regulation in their member states. And in pink, those that they already informed the European Commission that they will not implement water use for agricultural irrigation, but there are some examples that there are some member states that they are looking into reusing water, not in agricultural irrigation, but further in other sectors like urban irrigation of parks and golf clubs, so for amenity related activities, but also for industrial irrigation. One example, for example, is Poland that is now reevaluating the decision not to implement water use, and they are currently developing their legislation. So far approved national legislation that are aligned with the requirements of the water use regulation and also expands the scope of reuse to other sectors are Spain, Portugal, Cyprus, and Italy is in the almost in the final stage on the approval of the national legislation, and also Germany and Belgium they are on the way. Next one. And I also wanted to highlight about the initiative that is led by the Joint Research Center along with the European Water Association of the establishment of the European Water Academy, which has the aim to, among multiple objectives, has also the aim to increase capacity building and trainings. And we are developing a pillar on water use where we want to develop syllabus and training events to further develop risk management practices as required by the water use regulation. Next one. And one of the elements that we are currently working on as a training material is a serious game for water use, which is a board game, interactive board game where the different players are taking, they represent the several actors of the water use system, and they have to draft the risk management plan. We are developing this series game in the collaboration with the University of Oxford, and we already tested 3 times with in different settings with the different level of expertise, and get very positive feedbacks as a tool that can, from one side, increase the enhance the training and the understanding of what the risk management plan is, and also from the other side, also as a tool to develop team building before the whole process, the process is starting. Next one. And to conclude, like key messages and outlook, so water is a tool for resilience and public health protection. The regulation provides a harmonized, risk-based framework that look into protecting not only the public health, but also the environment within the One Health approach. The multi-barrier approach and the risk management plan, they can ensure the safety of the reuse of treated wastewater. We can look at, and we are looking at wastewater surveillance to complement reuse with epidemiological insights from the wastewater. And we will, as JRC, we are still supporting the implementation of the regulation. And also, to give a final message, we are entering the stage of the evaluation of the water use regulation, which needs to be published by June 2028. And now we are looking at how the risk management practices that have been developed within the European Union and see how to expand these practices in other sectors, and also understand if there needs to be a revision of the requirements or further support required by the European Commission. So thank you very much for your attention.
Thank you very much, Roberta, for the really nice and comprehensive presentation. I think we have 2 questions in the chat. I will just take the first one, which is just a comment as long as I'm sharing the screen, was about the map and Estonia being green but not listed on the table. But I'm assuming it's just a typo or something. But just if you want to comment quickly, and then the one.
Yes, it's a typo. Yes, Estonia is currently implementing the water use regulation for agricultural irrigation.
Yeah.
When you see this map, it means in agricultural irrigation.
Yes, so thank you very much. First one, I think the second question, I would then just take it for when we start the Q&A session and already move to the next presentation. So again, thank you very much. I stop sharing, and then our next speakers will be Fred Preun, Scientific Affair Manager at IDEX Technology. So you received your doctorate in 1998 from the John Hines Centers and University of East Anglia before joining IDEX as a research scientist in the same year. And you have worked closely with laboratories, expert and regulatory bodies around the world, developing new technologies, training analysts, and establishing best practices to optimize often complex technical procedure and generate robust methodology. But it's not only this that you've done. And in addition, you are also active member of the Water Management Society and the Standing Committee of Analysis in the UK. You also represent the Water Management Society on the EH34 Committee on Microbiological Methods of the British Standard Institution. And as part of this, you are also a member of numerous working groups tasked with developing new standards at country-specific and ISO level. And I will now share your presentation from my side, and then the floor will be yours.
Thank you. Thank you, Arthur. Just like to extend a welcome to everybody. Thank you for joining us today. And thank you for Roberta. Excellent presentation. I think it sets things up nicely for the rest. I don't see the presentation yet, Arthur.
Yeah, it's coming
Yeah.
right now. You should be able to see it. Yes.
Okay. So next slide, please. So I think we're all familiar with increasing levels of adverse environmental events. There's a lot of flooding events. The effects that these have are very surprising. One that I remember in particular was significant flooding on the Rhine River catchment, which affected countries in the west, Belgium, the Netherlands, all the way through North Rhine-Westphalia, Germany, to the Czech Republic and Romania. These events are becoming more and more common. We're becoming increasingly aware of the amount of these events that we're having. Next slide, please.
Oops, sorry.
So,
Sorry.
There we go. We're fine. Interestingly, even though we're having these adverse weather events, flooding events, additional events are also very common. Rivers are drying up, reservoirs are running low, we have failing crops. And I was interested in this because it's a juxtaposition between, flooding events, adverse weather events, and yet water scarcity is increasing. So I spoke to a colleague of mine who's head of microbiology at one of the largest water utilities in the UK. And what he told me was, next slide, please, we're having the wrong type of rain, which sounds strange, but it's actually true. When we get prolonged periods of light or steady rain, the water has time to soak into the ground. That helps recharge aquifers. And to an extent, when the water's percolating through the soil and the bedrock, there's some level of self-decontamination. What we're increasingly seeing are deluges of rain. So within a short period, very, very heavy rain, we have significant levels of urban runoff, significant agricultural runoff, flooding. Infrastructure and water treatment systems are often overloaded, and we have increased levels of chemical and microbial load within the water. And sadly, it results in reduced surface and groundwater levels. This is a reality that we're having to face. Next slide, please. The solution to this, as Roberta pointed out very, very eloquently, is increased reuse of wastewater. There are a number of suitable applications. We can now use it for industrial usage, for cleaning streets, and in particular, as we've heard, agriculture. We have lower treatment requirements for these applications because it's not drinking water. This is water reuse. But by increasing water reuse, we have increased levels of water resilience. We have to improve infrastructure. We have to improve policy. We have to anticipate and prepare and respond to floods, to droughts, and water scarcity. Overall, we need to improve our water security, the quantity of water that we have, the quality of water that we have for health, life, and our ecosystems. We need to have reliable sources, sustainable sources of water, and we need to use risk assessment to ensure that those water types are adequate for applications within acceptable risks. Next slide, please. The relevant directives and guidance, as Roberta has already alluded to, minimum requirements for water reuse, technical guidance on water reuse for agricultural purposes. Next slide, please. And we're trying to have a holistic approach. So when we think about water reuse, we often look for other guidelines to make sure there's some sort of holistic approach. So we look at the EU Drinking Water Directive, EU Bathing Water Directive. In microbiological terms, I'm a microbiologist, we're looking at similar parameters: Enterococci, Escherichia coli, Legionella, specifically when it comes to agriculture. Next slide, please. With regards to use in agriculture, Roberta's already indicated we have these 4 water quality classes, and we're looking at microbiological parameters such as E. coli, and we have different specific levels for each of these water classes: biological oxygen demand, total suspended solids, turbidity, and then when it gets to agriculture, we're currently mandating testing for Legionella species and helminths. There is actually, in my opinion, a really strong case here to focus on Legionella pneumophila. Why is that? I would rather use targeted methods for the #1 pathogenic cause of Legionnaire's disease rather than use an inferior method to try and detect a few more species that may not be relevant towards Legionnaire's disease. But that's a different discussion. Next slide, please. Again, use in agriculture, particularly with Class A water types, we're interested in E. coli, and we look at log reduction. So we're looking at equal or greater 5 log reduction, 6 log reduction for coliphage. And then with Clostridium perfringens, we're looking at greater than a 4 log reduction and a 5 log reduction for sulfite reducing bacteria. Next slide, please. There are other parameters that maybe we should consider in the future, particularly with the Urban Wastewater Treatment Directive. We're very, very interested in surveillance of antimicrobial resistance. We have to be aware of chemical parameters, particularly PFAS, these long-lived chemicals that generally don't break down. When it comes to agriculture, that's extremely important. We might want to look at viruses such as SARS-CoV-2, polio, influenza, emerging pathogens that we're only just starting to consider, such as non-tuberculous mycobacteria. And there are probably other parameters that in the future we need to consider based on risk assessment. Next slide, please. Risk assessment is absolutely critical, and this is a very, very basic example of why risk assessment is critical. In terms of agricultural use with water reuse, if you're using drip irrigation, the presence of Legionella is probably going to be fairly low risk. If we're using spray or sprinkler irrigation, where we're aerosolizing the water, Legionella is obviously going to become a more significant risk. So risk assessment is very important, and we have to go through this process to understand and ensure that the water quality is suitable for the intended application. Next slide, please. So finally, in summary, and again, thanks to Roberta for setting the scene for all of this, water is absolutely essential. It's an increasingly scarce commodity, and water reuse is an absolute requirement moving forward. The water quality has to be suitable, both chemically and microbiologically, for the application intended. So, and water analysis for chemical and microbiological parameters is also essential to ensure that quality. There are bare minimums that are set out in the guidelines, but we should be also considering additional options, and risk assessment is absolutely essential. One final point I will make, and this came out of a Water Europe conference recently in Copenhagen, and it's a recurring theme, and that the cost of water and treating water has to increase. It must increase. It's essential. We have to maintain or improve infrastructure. Levels of routine monitoring for chemical and microbiological parameters is going to increase. And so we have to deliver a clear message to the public that the cost of water treatment is going to increase and has to increase. And at that point, thank you, Arthur, and thank you, everybody.
Thank you very much, Brett, for the really nice presentation. And some complementarity, and I think I can more or less agree with everything that was said. And it's nice to see the complementarity between the two presentations. We'll now move to the third speaker, as I think we have one question that's more general, so we'll take it after it. So our third speaker is Herman Hernes, who is a senior scientist at SINTEF, an independent research foundation in Norway. You have been working in the water sector since 1991 with research, innovation, and research-based consultancy. Your expertise covers treatment processes and solutions for drinking water, industrial water and wastewater, sustainability assessment, and integrated water management with a focus on research recovery and circularity economy solution for the water sector. You have international experience from Sudan, Ghana, South Africa, and Macedonia, and a reference list that includes a number of large Norwegian and international projects, most recently as coordinator of the H2020 project Wider Uptake and Work Package Lead in the Collaboration Study Action CSO. You are a member of Water Europe Expert Group on Water Efficiency, Reuse and Circularity, and also the chairperson of the European Water Association Working Group on Circularity. And then today you will be talking about water reuse as part of the Wider Uptake project. So Herman, thank you very much. The floor is yours.
Thank you very much, Arthur, for the kind introduction. Also, thank you to the previous presenters. Welcome, everyone. I'm happy to be here at this webinar. As Arthur said, I will be talking to you about my background, or the outcome of this presentation is from the Wider Uptake project. Let's see if we can get this to work. Yes, I will talk a bit about Wider Uptake, just to give you some context. Move on to the risk framework we developed, talk a bit about 2 demonstration cases with water reuse, some lessons learned, and take-home messages. Wider Uptake was a Horizon 2020 project funded by the call for building a water smart society, 11 million euro budget, 18 partners with cases from Ghana in the south via Italy, the Czech Republic, Netherlands, and Norway to the north. And I had the pleasure of being the coordinator. Now, Wider Uptake was all about moving from a linear to more integrated and circular water management. And it was circular economy and solutions that was the core of the project, demonstrating solutions. Also, very important in the project was the co-development with stakeholders across the different cases. This meant that typically in a case there was a technology provider or a utility who sort of owned the solution, and then it was further developed to the project with the relevant stakeholders in the case and a part of a community of practice. And then there was also co-learning between the different cases. What we did, well, water uptake was more than water reuse, but we had water reuse for irrigation and in public parks, and also for agriculture in Italy, the Czech Republic, and Ghana. Then we also had fertilizers from sewage sludge and recovered phosphorus in Norway and Italy, soil improvement from sewage sludge in Norway, biogas also in Norway, biochar from sewage sludge in Ghana, materials for bioplastics from sewage in Italy, and also biocomposite production. So there was a range of solutions that were demonstrated in this project. And this also influenced what we were doing. To learn between these different cases, we had a set of cross-cutting activities. Today, I will limit the presentation to the first one, which was on monitoring and control of health and quality risks. And in this work package, there was developed what we call the water uptake risk framework. It integrated product quality, health, and environmental safety assessments to support implementation and inform decision-making. So it could safely take a recovered resource, turn it into a product, and place it in the market. And if the first pillar was on quality and compliance, while the second and third were on human health and environmental protection, respectively. Now, in the first pillar, if you to use the example of water reuse, you would differentiate between the quality coming out of the treatment plant, which was then the recovered resource, and the quality at the point of irrigation, which was sort of the product. This may seem elaborate in the case of water reuse, but for other types of resource recovery and reuse, this makes perfect sense. This framework was developed as a part of a PhD at the Norwegian University, NTNU, and part of work package 2 in the project. The framework adopts the disability adjusted life year per person and the chemical risk stratification ratio as to define health targets for microbial and health risks, respectively. And then the risks themselves were assessed by QMRA and QCRA, respectively. The testing and the validation of the framework took part in the later part of the project period, and it's published in the Journal of Clean Production, and you can find, it's also a deliverable, which you can find on the website that produced link there. This methodology was developed in parallel time-wise with the wastewater reuse solutions in the demonstration cases. And then these cases, therefore, initially at least, relied on other approaches also for monitoring and assessing health-related parameters. I'll now turn to the description of 2 of these cases where we had wastewater reuse, namely in Ghana and in the Czech Republic. So turning first to Ghana, in Accra, where they have urban farming, and these farmers, they normally rely on water from irrigation from ditches or channels, which can be often very polluted. So the solution we wanted to demonstrate in the project was to take wastewater from the wastewater treatment plant, which was normally discharged to the ocean after treatment, according to secondary treatment standards, polish that water in a dedicated treatment step, and supply it to the farmers via a tanker trucks and a facility for distribution of the water. These pictures show the various stages of construction of the demonstration sites. And to the upper part of the project, you can see the finished distribution system, the shallow draft storage, and the picture from one of the test sites where they were growing vegetables. The water quality monitoring in the supply chain from the wastewater treatment plant to the application by the farmers an assessment for irrigation was done according to the local Ghanaian standards on the wastewater treatment effluent and the EU guidelines, also for wastewater effluents. Then on the other guidelines for the irrigation water on metals and also on the content, how they were suited for vegetables. Key results reported was that the physicochemical results indicated that the treated wastewater was of good quality. The heavy metal content also in the vegetables were acceptable. The bacteriological quality in the shallow draft reservoir satisfied the EU guidelines, and the treated water had good quality for Vibrio, and the vegetables were also good general quality, and no cysts of Cryptosporidium or Giardia were found in the vegetables. So all in all, the monitoring and the results of that showed that this was a viable way to go. Moving now to the example from Prague. Here, the idea was to use reclaimed water to irrigate urban greenery. And they set up a demonstration site next to the central wastewater treatment facility in the city and demonstrated 4 different types of water quality for irrigation. One was from the river as a base case, and then it was the effluent from the wastewater treatment plant. This was a tertiary treatment plant, advanced treatment. They then had additional treatment by ultrafiltration, and the 4th one was ultrafiltration plus UV for disinfection. And then they had different types of plants, grass, bushes, and flowers in the demonstration site, where they also had it covered by a roof so that you wouldn't have any influence of rain. They had a comprehensive monitoring plan according to Czech national standards and FAO standards and EU regulations. Basic physiochemical parameters, heavy metals, nutrients, microbial parameters, and micropollutants. And they did a risk assessment according to, and in line with the wider uptake framework, where they used QMRA and QCRA. The results show that it's possible to use this type of water for irrigating plants. The water quality parameters were within the limits for all water types. There had levels of nitrogen and phosphorus was considered beneficial for plant growth. The plants showed no adverse effects here. Also, the accumulation of trace elements and micropollutants were deemed negligible, and also the soil quality that revealed that there was no adverse effects here. There was some effects compared to river water, but this was the thinking was that this was due to use of a roof, and without the roof you would have also a washout due to rain and snow. Again, this is reported, and you can find more details in the deliverable and also publications if you go to the website of the project. So what were the commonalities then between the 2 cases in Ghana and the Czech Republic? Well, for both cases, they had solutions were developed according to the local needs, a place-based approach, you could say. The wastewater treatment and further polishing was designed to provide the water with a quality that was fit for the purpose, and the monitoring of water quality and risk assessment was relevant for the local context. So I would say this was successful demonstrations with respect to the technical solutions and the results for water quality and the impacts on the crops and soil. However, governance-related barriers in both cases actually halted further application after the project. In Ghana, this was related to land use rights and the value chain for produced vegetables, which became long between the farmers who had to pay for the treated water and the customers in the supermarkets who would eventually buy their vegetables. And in the Czech Republic, it was related to lack of adoption of the water reuse regulations. Now, in wider uptake, we also saw that governance barriers were pointed to in other demonstration cases with the recovery of energy, nutrients, or materials from wastewater. So what we found was that you need to look holistically. You need to look at more than the actual application looking at your wastewater treatment plant and how to make the technical process of treating the water and delivering that. You need to have the whole value chain covered, whether it is for various applications and across the sectors. And in wider uptake, we call this to have a systemic circular economy solution, and that is comprised of the partners and stakeholders that collaborate to make this happen. It's of course all the technical aspects of it, the recovery processes, the recovered resources, and the application, and turning that into a final product and application of that. And you also need to have the business model. And to evaluate and develop such solutions, we developed in the project. We came up with recommendations and assessment tools covering wastewater, recovery of water, but also nutrients, materials, and energy. And apart from the health and quality risk assessment, which I briefly introduced, there was also other tools. These are available on the website and also on the Water Europe marketplace for further reference. So the take-home messages. Well, use of treated wastewater, you should consider both the value, the water itself, and the resources in the water. And I think to realize the value of this, you should target the most valuable resource in your case. Adapt the solution to the local context. So this is quite general, but I think it also fits with the wastewater reuse. It should be place-based and fit for purpose. So in the cases with recovery of reuse and reuse of wastewater and wider uptake, we demonstrate successful solutions, and they were developed according to the local needs and had a water quality that was fit for the purpose. However, as mentioned, the application was hindered by governance barriers, and this was a commonality between other cases also. So we believe that you need to look at developing systemic circular economy solutions where you look at the holistic part. You look at the stakeholders, you need to involve the stakeholders, the technical resource recovery with derived projects, and the business models to realize the economic value here or get this done. And development of this you then need to have a holistic perspective. You need to look at the governance and regulations, health and quality, circularity and resource efficiency, business models, and ultimately the sustainability of the solution. And taking such an holistic approach will enable you to address barriers early and developing or choosing and implementing a successful application. Thank you for the attention.
Thank you very much, Herman, for the presentation and for sharing findings from the wide uptake project. So we will now move to Q&A session. So please use the question and answer portal and mention to whom your question is addressed. Again, we cannot take your question as in chat or if you just raise your hand. Roberta, we'll start with you. We had a question from Jean-Francois. We'll go a bit like from the broader one to the narrow one. So you mentioned or you showed us a map with countries that didn't either opt in or opt out of the water reuse regulation. And the question goes as following. So do countries that do not intend to implement the regulation have to justify their position? Are those justifications assessed by the Commission, and are those justifications publicly available?
Yes, so the countries that they do not intend to implement the regulation, they have to invoke the Article 2.2 of the regulation, and they have to notify to the European Commission the reasons. So they usually present studies and reasons behind this. I'm not sure that the information will be publicly available. This is something I cannot answer based on my knowledge. We do have notifications for the member states. We know that the European Environmental Agency will launch soon the data reporting. So the member states will be mandatory to report the water use systems, and also there they have the possibility to notify if they don't want to implement water use, so they can communicate to the European Commission and the European Environmental Agency, and those information that will be for sure publicly available. And the reporting people will be open from, the first reporting people is from by June 2026. So we'll see the first year of reporting of water use systems and member states update.
Thank you very much. Then, so going a bit deeper, so we had also a question for you, actually. So the first one from Isabel that just say, two questions in regard to EU. So when will the EU regulatory framework officially accept/validate online rapid microbial method for reuse? And also, are there any plans on direct and indirect potable reuse? Just learn about such a project in Belgium, actually. And if
So
someone wants to jump after Roberta.
So regarding the online rapid microbial methods, so the regulation refers to the use of standardized and ISO standards methods to detect the requirements under the regulation for monitoring purposes. So I believe that once they will accept it by the standards and the ISO standard community, then it can be used in any plant, in any water use system. I do see the possibility to use for monitoring in addition, but still when you report the data, then they need to meet the standards that they are required in the regulatory framework. And we go by the innovation, so it's gonna, in the future, I'm sure the regular framework will align with advanced methodology that then needs to be standardized first. And regarding potable reuse, so there is no regulatory framework for potable reuse. There are common implementation strategies guidelines that have been developed by working groups on aquifer recharge, so manage aquifer recharge, MAR. But currently there is no indication, and this is something that is it's required by it will be covered by national legislation.
Okay, thank you very much. Yeah, Herman, Brett, if there's anything that you would like to add, do not hesitate to jump in.
Yeah, I was just going to make one comment with regards to ISO standards. Water reuse is obviously somewhat different from testing drinking water. It's a different matrix altogether. You've got different challenges, suspended solids, etc. And so people implementing ISO standards should really look carefully within the scope and maybe reach out to experts on the committees to ensure that the method they're employing is suitable for that particular application, that particular water matrix. Thank you.
Thank you very much. So then I will then stay with you, Brett, because we had an additional question. So which additional parameter not included in the EU regulation do you recommend to monitor?
How long is a piece of string? Certainly, again, it has to be based upon risk assessment for the particular application. Again, we gave the example where if you're using sprinkler irrigation, Legionnaire is going to be very important. As Herman mentioned, Cryptosporidium and Giardia are a particular issue with leafy vegetables. There is also some evidence that it can become entrained within some fruits and vegetables like tomatoes. There's limited evidence there, but so I think really you have to look at the application and you have to consider what the risks are for each microbiological parameter.
Thank you very much.
If the person in question wants to reach out to me, I'm happy to have a separate discussion. It could be a long one.
If I remember correctly, you had your email address at the end of your presentation that we'll share with the participants later today. So do not hesitate. And Charlotte, thank you very much. She said, thank you as well. Then I had one for Herman. So you presented also on Prague. And then the question was, were all options of treatment acceptable in Prague, or were there differences?
Well, for some of the parameters, there were no differences, but all the different treatment options gave acceptable results. I would have to go into the details of the report to answer the specifics there. So I would refer to the report on the website, and also the learned colleagues in Prague, which you can find the contact to there.
Thank you very much.
Sorry, the point in Prague, I think that the question wasn't the water quality or the monitoring results, it was the regulations.
Oh, thank you very much. Then we have, at least on the Q&A functions, still two. I will take the second one. So for everyone, so just tell me which one to of you wants to go first? What is a panel view on using reclaimed water suitable for A-class irrigation to enhance stream flow and wetlands in a region, so facing water stress? One of you wants to take it.
Well, I can take it. So, yes, the regulation applies for agricultural irrigation, and also mentioned that member states may use the requirements of the regulation for other uses, including environmental restoration. And this is a practice that is being regulated in Spain now. I mean, when I say regulated, it means that national legislation that they expanded the framework of the regulation to other uses. So Portugal and Spain, they did this, and in Portugal there are many examples where reclaimed water is used for wetlands, and also in Spain there are several uses on enhancing arid parts. And it's all based on minimum requirements. So table class A or B can be used, but what is important is it's all based on the risk assessment. So in this specific case, like wetlands, the risk needs to be assessed that the wetlands that will be used by the community. So you might have additional parameters of water quality that are really based on the use of the community of the area that have been irrigated with the reclaimed water. So it's not only the class, which is the key of the regulation, but it's also additional requirement based on the risk scenario that they needs to be assessed. And Portugal, for example, is developing also guidelines and on the specific use for amenity related.
Thank you. So if you allow me, because we are 2 to 12, I will take one, maybe two more questions, and then we'll finish. So I think one was prepared for you directly. So according to your last answer, we have to expect to update the risk assessments and therefore the authorization to reuse if the final use change, but the upward water treatment doesn't. Thank you.
I think we should be continually thinking about risk assessment and land usage and water usage. So risk assessment should be an ongoing process. For example, if we're using water reuse for agriculture and then we have adverse weather events and we get agricultural runoff back into the water system, it's a constantly increasing difficult situation. So risk assessment really, I think, should be done on a yearly basis, depending on application and the water treatment that's in place. If you improve upstream water treatment, then maybe your risk assessment has to take that into account. Again, happy to discuss further with the individual.
Thank you very much. And then I would like to take one from Rhino, because that was actually the first one today. So should the use of drinking water for toilet flushing be prohibited, and should separate water supply system be built for these purposes? So before, if one of you wants to take it or just share a personal opinion, actually, we know from some of EWA members that especially in Flanders, for example, it's slowly the case. So like if you rebuild an old house or if you build new ones, and you need to have two water systems and to basically collect rainwater and like to use it for flushing the toilet. So that's just one example. And yeah, if someone wants to share the opinion, but yeah, of course, it's especially, I would say, within the water reuse community, a bigger debate or question that pop up rather often. So yeah.
Absolutely agree, Arthur. I'm not sure a blanket ban on using drinking water for flushing toilets is appropriate or even implementable, but we should be future-proofing. So we're building new structures. We should be incorporating water reuse into their design.
Yeah.
Can I just add on to that comment, because I am very well what Beth is saying, and it points to the implementation part. It would require major revamping of infrastructure and solutions, and it's not just about banning the use of drinking water.
Yeah, and I can tell you, okay, like a ban as you both said, like would be maybe really a bit unrealistic or would need like massive investments. And I would say also, let's say, workers or workforce available in all the sectors in order to do all the work into all the household and everything that would like drive up the price and everything. But I also know we have, I think it's a French SMEs that also do tanks that you can set up basically under the floor of your bathroom, and then just collect the shower water or the bathing water, and then just use it again for you. There's the toilet. So you see like already either from rainwater or for reusing directly and so on, from the shower. So you see already this couple of solutions already on the market. Let's see which one in which how is it going to grow, I would say.
It's basically about assessing what is the most sustainable and water smart way of lessening the pressure on water resources.
Exactly. And then, if you agree, then the last one, then to Roberta, could we expect the integration of indirect reuse, exploiting existing irrigation channel very common in northern Italy?
So the question of the indirect use, we are looking into that, and so there are. So I will share some outcomes. So in the evaluation period of the water use regulation, there is this sentence, this article mentioning of expanding the water use regulation to indirect reuse. However, in the drafting of risk management plan for water use systems in Europe, this is a practice that is the existing channels being used and receiving both reclaimed water and water from other surfaces, other sources like surface water, is already established. So in the framework of the risk assessment, when the reclamation facility is producing water for reuse, it really depends on the volume that you are discharging in the channel. So if this is a relevant volume, and to achieve this, it needs to be based on the risk assessment framework, and this would include that I will assess the quality of also the other source of water until the end use. And this also in the line with the use of the multi-barrier approach that can ensure that the safety of the quality of the water from the point of discharge to the point of use, including mixing with the other surface, with the other source of water. Yes, then we have to also say that this is due because there is the perception also that there is a perception. I mean, there is the surface water, the other water is not monitored, and the quality of the water cannot be directly understandable at the beginning. So it really needs to be assessed within the risk management plan of the water use. But this will be for sure be part of the evaluation, and also with the guidance of the multi-barrier approach, we will try to address examples on how this can be integrated and give further guidance in the future.
Thank you very much, Roberta. So thank you very much to the three of you for your presentation today and for also agreeing to sharing them with the participants. So we will share everything, all the presentation with everyone today. So recording will be then available by the end of the week on the EWA YouTube channel. Again, so this webinar was part of our broader EWA activity towards IFAT, and I would like to inform you that our next webinar on harnessing artificial intelligence for water lesson learned in Future Horizon will take place on January 15 from 11 to 12, and we'll also have one in February, about desalination. So again, thank you. You can stay in touch with us with our website, LinkedIn's channel, YouTube's. So that's the website. You can also subscribe to our newsletter, and please also take the 2 seconds to provide your feedbacks about today's webinar. Once again, thank you very much for everyone. We hope to see you soon. And yeah, feel free to contact me and all the speakers. That's nicely also offered it as well if you have any further questions. And Roberta, in the future, you can always contact EWA to promote water reuse and to support the GRC work on either evaluating guidelines and so on. So thank you very much again, everyone. I hope that you have a good day and the rest of the. Thank you.
Thanks, everybody.
Thank you very much, everybody. Bye-bye.